Hi there, I'm Hao, and it is just another video of me solving random equal problem. So let's begin. So we have a Pacific Atlantic water flow here. Um, it is an N by N rectangular island that borders both the Pacific and the Atlantic Ocean. The Pacific Ocean touched the left top edge, where the Atlantic touched the right bottom. Uh, and is partitioned into a grid of square cell. You're given an n by n integer matrix height where heights of R and T represent the height above the sea level of the cell. Okay, the island receives a lot of rain. And the rainwater can flow to the neighboring cell that directly north, south, east, and west, so four direction. Right. If the neighboring cell height is less than or equal to the current cell's height, the water can flow from any adjacent cell to an ocean to the ocean. Okay. Return a 2D list of grid coordinate results, where result I denote that the rain can flow from cell R1C1 to both Pacific and the Atlantic Ocean. Okay, so if you look at the highlighting note here, right? Let's say you look at 5 here, right? You can flow to mm, so if what is it? Right. A cell height is less than or equal to the current cell, right? So if it is less than, then we can flow to here, right? And we can flow to here, and we can reach the Pacific Ocean. But we can also flow this way, right? Because 3 is less than 5, 1 is less than 3, right? And we can reach the Atlantic Ocean, which is in the number 5 here. Note 5 can reach both Atlantic and Pacific Ocean, right? Same for 4, right? We can reach that, right? Same for 5, it's already touched, right? Same for 6, right? 6 can flow to 5, right? 7 can flow to 6, can flow to 1, right? So on and so forth, right? What if we look at let's say 2, right? 2 can flow to 2, right? 2 can reach the Pacific Ocean, but it cannot reach the Atlantic because 3 is bigger than 2, right? And 4 is also bigger than 2, so it cannot flow anywhere from there. Okay. And then we just need to return a list of the sail that is able to reach both Pacific and Atlantic Ocean. Okay. So what can we do? We can iterating over each node, and then for each node, right, we can check we can do a search, a DFS on it to see if we can reach both Pacific and the Atlantic, right? Look at every single path, right, to see if we can reach the Atlantic or the Pacific. We need to do it again for like every single node. So average time complexity would be O of n times n square, right? That is not good. Another thing we can do, we can uh, think about it in a different way. So if you look at the node on the edge here, right, the node on the edge, they are already touching the ocean, right? They are already touching the ocean. So we can start from the node on the edge here and go as far as we can, right, backward. So instead of flowing down, we are flowing up. We're going like back backward, and we have a set to keep track of the node that we can reach from the Atlantic coast, and the same thing for the Pacific coast, and the intersection between the two set will be our result, right? So let's see an example here. So let's start like from the Atlantic coast. So previously, right? If we start from a node, we need to go down. The neighboring cell has to be equal or less than the um the current cell, right? That's why we can slow down to reach like the water here, right? Some fish, right? Some fish. Uh, yeah, okay. But if we go backward, right? If we starting from the ocean, right? The water, then we need to go upward, right? So we have to the condition will be reversed, right? So if the node up here, right, if the next node, if the neighboring cell is bigger than the current cell, then we can keep moving, right? Like this, right? So like if we have something like this, right, and um, the water here cannot be able to flow into the ocean, right? It has to be larger or equal to the current cells, right? This is possible, but like something like this is not possible. Okay, so we can start from the right side here, which is for the Atlantic, right? Phi. So phi, we need to find something that's bigger than phi, right? Because we are going from bottom to the top. We're going backward. So nothing is bigger than phi. So we just stop here. Right? Next four. For us, we can go here, right? Because four is equal to four, and then nothing is bigger than four, right? So we stop. So four here, right? Sorry, one here. Um, we can go three because three is bigger than one. Five, five is bigger than one. Oh, and remember that we need to keep track of the visited set for the Atlantic side, right? So that we don't run into infinite loop. So three, we can go to five here. So we stop here, right? Because four, three, and one are smaller than five. So we stop here, right? And we can also go to four, right? And we stop here, right? Because oh, and we can also go to five and four. Right? One, three, four, five. Um, and we stop here. So the last one is four. We stop here because nothing is bigger than four. So same for two. Nothing is bigger than two here. Four, but four we already visited, so that doesn't count. One, we can go here, right? And stop here because nothing is bigger than one. Same here. One, we can go to five. We can go to seven, right? And from five, you can go to six because six is bigger than five. And then seven is bigger than six, so we can also go here. And we stop. So the red node is all of the node we can reach from the Atlantic Ocean, right? So now we can do the same thing for the Pacific Ocean here. So from one, we can go to two, two, three, right? And we stop there, right? Because four and five, we already. Oh, sorry. Yeah. We had to. We can go to four, and we can also go to five, right? Because five and four are bigger than three. So from the node four here, we can also go to four, right? Because four is equal to four, and we stop here because we don't see anything bigger, right? So we can start from two here. So two can go here, right? Three is bigger than two. Two is bigger than two. Four is bigger than two, and we stop there. Uh, Same thing for two. We can go to three. Um, oh, from four here, sorry, from four here, we can also go to five and seven, right? I didn't see that. Okay, five and seven. Okay. Uh, yeah. So, yep. And then two, we can go to six, right? Six, we can go to seven, right? And then five, right? Five, we can go to six, we can go to seven. So I believe that is it. right? So the overlap node or our result here, if you look at this part, right? So the part that I highlighted, right? The node that have both the red circle and the green circle or the intersection, right? These nodes they can be reached from both the Atlantic coast and the Pacific coast. So we can just return those, right? So that is the idea here. So let's go ahead and code this up. Um, we need a few constant, right? So rho equal to house and length is equal to I 0, that length. And then we want our result array, right? Okay, and we can return the result at the end. We want to iterate through. So what do we want to iterate through? We want to iterate through the Pacific coast, right? Pacific coast and the Atlantic coast. Atlantic, Atlantic coast, right? Uh, so for the Pacific coast, we start from 0, 0. Okay, let's say we are looking at this row right here, right? This row. So that is row 0, right? So we can just do the column here. Column equal to 0. Column is less than false. Column plus plus. And we can run the DFS uh, on each cell here in the first row. So row is 0 and the column is a column, right? So 0, 0, 0, 1, 0, 2, and so on and so forth. Um, and we need the also need the business set, right? For both the Atlantic and the Pacific. So Pacific and what the set Atlantic is equal to a new set too, right? And we want to pass this in Pacific. Okay. Same thing here. So now we are looking at the first column, this column here, right? So our row will be the variable here, and our column will be 0. Okay, row, right? So our column will be 0 now. So we have 0, 0, 1, 0, 2, 0, so on and so forth. We are onto the Atlantic coast, and we were looking at the last row here. Sorry, the last column here, right? So our column will not be changed. Uh, row, oops, rows, yeah. So our row will be the variable, and our column will be the last column, right? So column minus 1. Right? And we need to pass in the Atlantic instead of the Pacific. Right? So the last one is the last row, right? For the last row, the row won't be changing. So the row will be the last row, which is row minus 1. And then the column will be the variable. Okay. All right. So let's create our function for the DFS. Okay, sorry. So row, column, then visit directory. Okay. So what is our base case here? When do we stop? We stop when we are outbound, right? So if it is not inbound, right, then we just return it. So let's create our inbound row and column, and return row less than 0, column is equal to 0, row less than row, and column less than column, right? So that is the first base case, right? If it outbound, we return. Um, and then we need to also check if the neighbors is valid, right? So we need to keep track of the previous height, right? The previous height. So let's say we are looking at node 1 here, right? We going to node 2, right? So we need to check that the height of node 2 is greater than. So the current height have to be greater than the previous height, right? So so if the current height is smaller than is the current height is have to be greater than or equal to the uh, previous height. So if the current height is smaller, then it is invalid, right? It cannot flow downward toward the ocean, so we just gonna return, right? Or the previous height, current height, the current height is the row and the column, right? Is less than the previous height, right? So we return. We need to keep track of the previous height, right? And the previous height will start out uh, at grid of something something, right? So for this one is 0 column, and this one is row and 0. This one is row and column minus 1. This one is rows minus 1, and then column, right? Okay, so what is our base case here? Let's think about it again. So the first case, like, we stop when we are outbound, right? Outbound. The second case is when we reach an invalid height, right? Invalid height, which means the height of the current cell won't allow it to flow like to the ocean, right? So we just stop. And the third case is what? The third case is when we visit duplicate node, right? Duplicate, right? So we need to we account for that, right? Because if we visit the visit node, we will be stuck in the infinite loop. So or visited dot pass the string of row and column, right? Okay, let me clear this so we can have some more space. Okay, so that is our three base case. If we are outbound, or if we reach the duplicate node, or if we have invalidate, we just return, right? Okay, so if it is valid, what do? We add it to the set, right? So the visited here will either be Pacific or Atlantic, depending on what we are adding it. We are passing it. So would be the string of row and column, right? So after we add, what do? We just keep exploring, right? Keep exploring forward, right? Left, right, up, and down, and top and bottom, right? For neighbors. column, BFS of row plus one, column, BFS of row, column minus one, BFS of row plus one. Okay. And then, yeah, if it is invalid, we return. And then if it's valid, we add the cell to the visited set. And then we just keep exploring, right? And then I noticed that we forgot to add the previous height here. So the previous height would be the grid at row and column, right? So like the current height now will become the previous height in the next DFS call, in the next recursion call, right? So we have the previous side, the row and the column. What else? We also need the visitor cell, right? So let's add that in also. Okay. So we do the same for the Pacific and the Atlantic. So at the end, right, we just have to iterate through the matrix again. Row plus plus, for column, or the zero, column, plus the columns, column plus plus. And what do we want to do? We want to add something to our result array, right? The string, we want to add the row and column, right? So we want to add to the result array, the cell to the result array, if and only if the cell can be reached by both the Atlantic and the Pacific Ocean, right? It has to be the cell has to be exist in both sets, right? So we can do if, so we can create a key here. The key for the string of row and column, right? And if key is in Pacific, right? And the key is also in the Atlantic, then we push, right? So that's pretty much it. Okay, grid is not defined. Oh, it's not called grid. It's called height. So height. Okay. We are not returning anything here for some reason. We're returning the result here. Oh, we need to push in the result, right? If I call to code the method here. Push. Let me double check everything here. Visit and add string of row and column. Uh, passing the Atlantic here, right? Yeah. Let's fit here. Column, row 0, row, column -1, row -1, column. I think that I use a wrong method here. As key. As key. Yeah. Yeah, I use the wrong method for the set. Okay, let's try again. Okay, submit. And it worked. Thank you for watching.